Hello everyone, welcome to AI Anytime channel. In this video, we are going to write code to deploy our chatbots. So there were few requests that I should also create videos on deployment. There have been some videos on chatbots, like I've created videos and shown that how you can use a large language model to create chatbots or some conversational interfaces on your documents or different kind of data like CSVs, audio, videos, etc. And some of you requested that can I also create a couple of videos on deployment, that how we can deploy these solutions that we are building on cloud, for example. And so I just wanted to create a video to show you that how you can deploy these chatbots or the solutions, the LLM powered solutions or the generative AI powered solutions that we have built. So mainly in this video we are going to use container technology. We are going to rely on Docker to create Docker. First we'll write the Docker file, uh, and we'll write the code mainly, inside that Docker file to create Docker image, and then we'll run this application within a container. So if you are not familiar with Docker is a container technology. So I'm not going to cover Docker in this video. There are so many videos which is already available on YouTube where they talk about Docker. Docker is one of the most important technology in the last 20 years. I don't know if we should call Docker a technology. I think we can call it container technology. Docker is a tool, by the way, if I'm not wrong, which was created by a couple of guys from France, if I'm not wrong, but I have to check that. And after Docker, it's very easy, mainly on the ops, on the DevOps side, that how we can use Docker for this, to deploy this, to remove the dependencies and all those version issues, right? Mainly. So we're going to rely on that, and we'll write the Docker file for this bot here. You can see on my screen it says chat with your PDF chatbot, all open source, runs on CPU. So I'm going to take the code here from my GitHub repository. You can see this is the repository, chat with PDF chatbot, and you would have already used this code if you have seen my previous video, this video that I'm talking about. And we're going to create a Docker image out of this, run this within a container, and then we'll deploy it here on Microsoft Azure. We are going to first push our image on container registries. You can see here I am inside container registries. I'll create a container registry here. You can also push your Docker image to Docker Hub. If you are not familiar with Docker Hub, you can just come here and click on Docker Hub, right? It's the official container image library. So the entire Docker community, they push all of their images. If it's in public domain, they put it over here on Docker Hub, and also privately you can also do it completely on enterprise grade as well. They give you private access and all. So you can also do it. Probably I have not pushed the Docker image on Docker Hub. It doesn't make any sense then to create this video, because I assume that you want to deploy this inside a cloud that you can control it, mainly, or the registry that you can control it. Of course you can. I think even Docker Hub gives you one private repository in free, but I'm going to push this on Azure Container Registry. You can do it on AWS as well, or GCP as well. Most of the clouds are like same, right? So the main agenda of this video is to help you understand the logic, that how you can take the same logic and use any cloud you want to deploy these applications. I'll create a new resource group for this. Let me call this AI Anytime or something like this, and then I will give an instance AI Anytime, the registry name. So let's give it AI anytime.azure.cr.io, and you can see it's available. Let's keep East US. I'm okay with it, and I'm gonna go with standard here, and then I go on next, networking, private access recommended, only available for premium SKUs. So let's keep this. Now let's go to encryption, everything looks good to me, I'll click on review and create. So what it will do, it will create a container registry for me where I can push my Docker image that I will create it locally. Once we put our Docker image over here in this ACR, Azure Container Registry, I can use that image to basically create a container instance and run my application within that, like within a container through that instance. I can also use an app service to do that as well. So it will take a little time. You can see it says submitting deployment. If you don't have Docker at the first place, you have to come to docker.com, and it says I love Docker. I'm a huge fan of Docker, and I've done the study on Docker through how they started, the founders of Docker, the creators of Docker, and you should read that as well. It's very fascinating, the entire story behind Docker. And it says develop faster, run anywhere. And also we have that tagline of it, run SIP anywhere that you can SIP it to. So you can see it says download Docker desktop. If you are on Windows, you can use Docker desktop, and also on Linux. So it's available across operating system. It's OS agnostic. You can use it anywhere you want. Build, share, run, SIP, orchestrate through Kubernetes if you have multiple Docker containers over there. You want to upscale the solution. You want to scale the solution. You can orchestrate the containers using Kubernetes, but that is beyond of this video, so we're not going to cover those things. So this is where you can install Docker. You need to have virtualization enabled for this if you are on Windows, and that's it. So let me do one thing. I'll give the link in the description, guys, for Docker and Docker Hub, but pretty much available on the internet. You can just write and search it. Now this video, chat with PDF chatbot, we are going to deploy this, and then this deployment is complete. Go to resource, and now you can see that I have ACR with me where I can keep my Docker images. I can push my Docker images over here, and that we will do it. I'll create a couple of videos in this playlist, guys. I think this is an important playlist. Let's create a separate playlist for this. We'll call it LLM deployments or something like that. Okay. Now I'll come inside this chat with PDF, and let me open this in terminal, and I'm on Conda, by the way. I'm just gonna open this in code, and you can see here is my chatbot app.py. If you want to learn the chatbot development, please watch this video. I'll give the link in the description as well if you haven't seen this video yet. So what I'm gonna do here in this case, I'm gonna create a file called Docker file where D remains capital, Docker file, and here I'll write the code for my Docker file. So I'll explain. I'll write a very simple Docker file for this Streamlit application. It's a Streamlit application. Now there are different way of writing Docker files as well, depending on what kind of microservice, frameworks, libraries, etc. you are using. Now this is done. I hope you got the understanding. You need to have Docker installed in your system. If you are on Linux, it's very easy to install. If you are on Windows, you need virtualization enabled, and you can install Docker desktop there, and then you can get started. So let's write the Docker file for this, guys. And you know that it's a Streamlit application. So let me show chatbot app.py here. You can see it says import Streamlit as ST. So what it means is that we have to write a Docker file for a Streamlit or a Python kind of an app. So the first thing that we need a base image. Now base image is nothing but the tool that is going to run this application, the backbone. It can be a programming language, it can be a framework, it can be a database, it can be different kind of base images that you might require to run your application or solutions inside a container. And for this, as we have a Python, so we call it from, and I'm going to use Python 3.10 in this. So you can see I'm writing from Python 3.10. Now what I'm going to show you, okay, if I come here on Docker Hub, and I can just search, for example, Python, and when I click enter, you can see that I have official Docker image of Python over here, which says okay, updated 14 days ago, and the community works behind it, right? So it's open source, and you can see minted by the Docker community. Now the latest one is 3.12 that I will never recommend, at least for the next few months, because LangChain, etc., that dependencies might not be compatible with this. So you can see all the versions over here, and we are relying on 3.10, and there are different images. Now if you see this from Python 3.10, by the way, I'll just minimize this for now. Here I'm using the base image, the official image of Python 3.10. Now you also have options of something called Slim Buster. Now if you only want the minimal Python, to run your Docker container, with the app within the container, you can also do from Python 3.10 Slim Buster. It will take less time. So the entire size of your, all the layers within containers, right? Once we count it for this app, it might goes like 10 to 20 GB. It's become a huge file for you, right, to run that. And if you want to reduce the size, within of all of your layers combined together, you can use Slim Busters and Bullseye and Slim and Buster. Or you can find it over here. You can see Slim Bookworm, we have Bullseye, we have Alpine, we have different images over here for Python, and it goes same for all other programming languages, frameworks, or libraries as well, right? But I'm going to show you just base because you can play around it, guys. So the first thing is that we need from Python 3.10, which is an official image on Docker Hub. And the next thing is we can create a work directory here. So what should be our working directory? So let's set a work directory inside the container. Okay, so the work directory is nothing. I'm going to call it app. Pretty much straightforward thingy here, and I'm setting my work directory as an app. And the next thing is I'm going to copy the requirements.txt file. You can see we have a requirements.txt which contains all our dependencies and libraries that's required to run the application. So I'm going to write copy and requirements.txt. So requirements.txt within the same folder that we are in, right? So I'm just going to do dot here. Now what it does is it's copy the requirement file first to leverage the Docker cache. Okay, the Docker cache that we have. I'll explain when we are executing this. Now we have copied this. Now let's write the run command to install all the dependencies. So for that, how do we write it? It's pretty much straightforward. We know it already. Run. So we have from, we have copy, we have run, we have expose, we have cmd. These are the keywords to write your Docker file, and how you write from top to bottom. You just set some instructions, and based on that instruction, all of your layers will be created within your container. I'll show you when we are executing this. Now what I'm going to do is run pip install -r requirements.txt. That's how we install, right, when we create a virtual environment. Now here you can do a couple of things just for your information. If you want to only install through trusted sources like PyP, you can define that as well within your Docker file. You can also define a timeout default here, and I will do that because we are going to rely on PyTorch, Torch, etc., NVIDIA's CUDA, CNN if required. That might take little time, and once you lost connections, meanwhile, then it might break, right? So let's set a default timeout. So I'm going to say default, and I think it's something called default timeout, and I'm going to give 100 here, and let's call it future. Excuse me. Now also handling the timeout issue here, because when you install a lot of libraries and big libraries, sometimes your bandwidth might not be that good, and you might not get that connection, right, to install that. So that is done. Now let's copy the rest of the application files to the containers working directory, that we have set on above. So dot, and what I'm going to do here is I'm going to expose a port here. So we know that Streamlit app runs on port 8501. So I'm going to expose that. If you're on Flask, you can do it either 5000 or 80. If you are on Fast API, you can again do 8000. So it depends what kind of backend I were using. For Streamlit, I'm going to keep expose 8501. That's what Streamlit default port is. Expose, and you can also basically map this on Azure itself later on. Maybe we can try that out when we reach that stage. Now I'm going to write the run command, the cmd, that okay, this is going to be the final command for this application. So we are going to define how we run a streamlit file here. So I'm going to say streamlit, and I'm going to give comma and run, and then excuse me, and then I'm going to write my file name. So my file name is chatbot underscore app py. So chatbot underscore app.py, right? This is what I'm going to do here. If you are running a Flask application, you will probably do python app.py or something like that. If you are on evcon with Flask fast API, you will probably do evcon run app or app main or something like that, or you can define that within your main function and run python app or main.py. So it depends what kind of framework or libraries or backend, whatever you call it, you are using. So this is the minimal. I'm not the best, guys. These are not the best practices, and you should explore a bit when you are writing your Docker file, but these are the minimum requirement to run your application within a container. So we are okay with our image, our Docker file, guys. Now we'll create an image. We'll create a Docker image. So let me show you what I mean by that. The first thing that I'm gonna show you, if I already have any image, so sudo docker images, it's asking for my password, and you can see I don't have any image right now. Probably when you install it for the first time, you will have an image called hello world. Okay, I've deleted that, I don't need it. This is the command that to check an image, and if you want to see if there is any container which is currently running, it's called ps. You can see there is no container id, there is nothing that it's running right now within the Docker kernel. Now what I'm going to do here is, sorry, Docker daemon. Okay, now what I'm going to do here is I'm going to create this Docker image for the file that I have created, the Docker file for the application, the chatbot that we have. You can see we are writing for this one, chat with your PDF chatbot. And now let's do that, guys. So what I'm going to do here is I'm going to run this a command to create something called sudo docker build. So I'm going to use the build command, and I'm going to write an -t which accepts the input for the name of that image. So I'm going to call okay chatbot img. I'm going to use dot, which means okay, my Docker file is in the same folder where I'm executing this command right now. If you have Docker file somewhere else, and if you're running this from somewhere, some other terminal or directory, then you have to pass that entire path, okay, of your Docker file that you have. So what I'm going to do here, I'm going to hit enter, and now what you are seeing is it says I am loading metadata for Docker IO Python 3.10, which is our base image, and it's going to now install all the required dependencies and everything over here. You can see it all the, so basically the checksum to validate or to cross verify. You can see all the SHA-256, the checksum over there, and it says load build context. So it will start creating layers on so there will be multiple layers within this container, and we'll see in the last. And now you can see, so probably this will take a bit time. It might take up to few minutes as well, depending on what kind of lab dependencies we have. And for me, I think it might take around 10 to 15 minutes. So let it happen. So what I'm going to show you is, let's come back here on Azure container registry. You can find your access keys here, because we have to log in from our terminal, the Azure CLI, or from the terminal to authenticate with this Azure container registry, where we can probably push our code. Let me see if I can admin user and enable it if it's required. And I'll just come over here and overview, and now you can see we have a lot of things here, guys. We have logs. If you face any issues with your thing, we have webhooks. If you keep pushing your Docker image, how you can enable webhooks there. If you are using this image in some app service or something like that. Then on the repositories, probably, right now we do not have anything here. You can see there is nothing right now. We'll have something once we push our image over here. Okay, let's go back to overview, and what I'm going to also do is, okay, let's see here. Now you can see it's collecting torch and installing all the dependencies and requirements that we have right now. you can see all the layers by step from top to bottom. So work directory app, it has created it now. If it has set that as app as a work directory, it copies all the requirements within that, and it's now installing everything. Once it gets done, probably right now I'll assume this, I'll pause this video and I will resume the video once it gets completed, this Docker image for this one. So let me pause the video, guys, and I'll resume once it is done. So as you can see, guys, that now it's in the last layer. You can see 9 out of 10 here on the building, and it has installed all the required dependencies on libraries, and it says now exporting to image, exporting layers. So all of your layers within that containers that we have, right? And it will be a little big. You can see the time it took for installing all the requirements was around 956 seconds, which is a lot of time, right? And you can see it's now says writing image. You have a checksum over there if you want to cross verify your image, and it says naming to docker.io library chatbot image. Now what I'm going to do here is to show you that how we can see the images. So let's call you can see that we have one image which is around 14.6 GB, not that big. I have seen Docker image size around 30-40, even more than that as well, 30-40 GBs. Now you can see chatbot image 55 seconds ago. So we have one image, and we're now going to run this image. So what I'm going to do here is do docker and run. You can also do -d if you want to run within a daemon. If you want to run within this daemon, so for example, if you have some remote machine or some within VMs, if you want to keep it running, and you can also do that within a daemon and using -d command. So this is how it looks like. If you do -d, you can also then do -p if you want to run this on any particular port. Like you can do port mapping as well. If you have multiple Docker images running on fast API, then you can do 8001:8000, 8002:8000, 8000n:8000, depending on how many images that you have on same fast API thingy, for example, or Flask, for example, and then 5000. So you can also basically manage this within your terminal as well. You can also write config files, etc. So in this video we are not focusing on Docker Compose, for example. I don't know if I should talk about Compose in the same video. I think we can use Docker Compose, which is better in, like, of course Docker Compose is better if you see this way that I am currently doing is because now if you want to change some libraries or something, if you want to update your Docker file, you don't have to rebuild if you are using Docker Compose. So that has other features and benefits that we will see, and maybe if you are familiar with Docker, you can use Docker Compose for this one as well. So this is how you can do -p for port as well. What I'm not going to do is, because I already have expose port in this Docker file, I'm just going to use chatbot img. So you can see it says sudo docker run chatbot img, and I'm gonna just hit enter here. Now when I hit enter, it says you can now view your Streamlit app in your browser. So what I'm gonna do here is I'm just gonna copy this, by the way. Okay, let's copy link, and I'm gonna copy the link, and I come over here, and here I'll just gonna paste this link, which is a chatbot app Streamlit. Let's see if we get any error or something like that. Okay, if you get any error, that's the problem with the Docker file. This way of creating a Docker image, probably again you have to rebuild the image, right? And we'll see it out. Now when I click enter, it says chatbot app or something like that. You can see it says chat with your PDF. We have built by AI anytime with love. Upload your PDF. The same application, you can see it over here as well. Excuse me, I'll just show you. You can see the same app that we have built. chat with your PDF. So you can see the same app over here, upload your PDF, and now it's running within a, if you see it over here in this, right, it's running within a container. And what I'm gonna do over here also is, let me open a new window and write something for you. So I'm gonna say sudo docker ps. So when I say that, you can see that it's running inside a container, and it gives a name called flamboyant ramen. It's on port 8501 TCP as the protocol over there. And then we have a command that it runs the app, streamlit run chatbot app.py, and our image and a container ID as well. So you can track it out over here with the ps command. It's running. That's what I wanted to show you with this. And now let's upload a file. So I'm gonna upload this file, guys. So I'm just gonna use, let's see which file we can use. I'm just looking for a file. There's no file inside it. Where is that file when we need it? Let me see. Not inside llama for you. It's a huge file. I want to take a smaller file here, guys. Yes, so I'm gonna use this file. I'm gonna use this file, and it will probably, you can see its embeddings are in process, running data ingestion, etc. And it will take some time. Now, just for your information, guys, you can find out the GitHub repository here if you want to deploy the same bot, or in your case, if you have any other bot as well, any other Streamlit application, the Docker file should at least do the job over there, right? It can work at least. Now, and you can see, let me just minimize it for here now. Okay, you can see the embeddings are in process and everything is running right now. You have a PDF viewer for your file and the entire app. Here you will have an app interface, guys. That's it. So let's wait for it, and it will take a little time. So maybe we'll create maybe let's then meanwhile also do one thing. So here on this, let's go to home, and on home what I'm going to do here is I'm just going to search for something called container instance, and you can see we have something called container instances. So I'm going to create a container instance here, and on this create container instances, I'm going to create a container, and I'll keep a resource group, for example AI anytime, that I have earlier created for the container registry. Now if you don't know what container instance is, you can read it over here. It says Azure Container Instances allows you to quickly and easily run containers on Azure. So we already running this app within a container locally. Now we can take the same image that we have and run within a container here on Azure without managing servers. So it does everything for us, or having to learn new tools. ACI offers per second billing to minimize the cost of running containers on the cloud. It's very affordable as well, guys, on that regard. I'm going to give a container name here. I'm going to call it Chatbot IMG. Yeah, that's fine. Or let's call it Chatbot app or something like that. And we're going to keep it standard for now. And you can see that it has image source. There are 3 options for that. Either you go for quick start images, you can select a quick start image over here. As a default, you can see there are a few images, Alpine, Linux, for example. Or you can select a container. If you click on other registry, probably it's expecting from your Docker hub. That you can also do it. But I already have, or I'm gonna have my image within this container registry, ACR, that we created right earlier. So I'm gonna select this ACR. You can see right now I don't have. It says no container image was found in the selected registry. Choose a different container registry or learn how to upload an image to a container registry. So let me also open this here. Now, so what we're going to do here is that we're going to push our Docker image in this container registry, and we are going to leverage this on this container instance to run our application within a container instance, and you can configure domain and everything over there. So I'll do this in a bit. Once that gets done, change size, and you can increase size of the container, number of CPU cores and memories and GPU type, and so you can increase this. So memory GB, I'm gonna use 16 GB for this memory GB, or let me just you can increase it to 32. So I'm gonna increase it to 32 for now. This number of CPU cores, I'm gonna keep it. Let's keep it 1 for now. It's okay, and then I click on OK. on CPU 32 GB memory. We are not using any GPUs right now, and it's will determine OS, Linux, etc. For example. Now let's come back over here. And now you can see it says embeddings are created successfully. So our app is running, guys, the same app that we have over here. So now our app is running within a container. So you can also ask a question like, what is climate change or something like this. Now ask this question on this bot that we are going to deploy, and let it answer for now. And let's come here. I'll just do never for now. Okay. So this is what I wanted to do locally, and what we are going to do now is we are going to basically take that image, and we are going to push that in this container registry, guys, because it's running locally. Now we can't deploy it from our local system, right? We have to push it to a container registry or a Docker hub if you want to use it officially, or on any other cloud like AWS or GCP. So let's do that, guys. So for that, what we have to do is that we just have to first, let's tag this. We have to tag it. So let me just do images. You can see the image that we have right now, and if I just do PS, there is no container currently running. We have to stop the container, as we just tested it out that okay, we are able to get the results and all the embeddings are working and everything. Now we're going to deploy this. So what I'm going to do here now is, okay, we're going to tag it. So the first thing that we have to log in to this container registry. So there are two ways of login. Either you authenticate with Docker itself, or the first thing that I will show you that you can do with AZ, Azure CLI. So AZ CLI. So AGACR login, and then AI anytime, which is the repository name, probably a container registry name. You can also do AI anytime.azure.cr.io, but it will basically omit the Azure CI. Then you have to pass expose tokens, and in that you can pass your access token that you have, right? And that's how you can also log in. But what I'm gonna do is I'm gonna log in through sudo docker login AI anytime .azure.cr.io. So this is the command to authenticate with your Azure container registry. Sudo docker login, my container registry name. I'm gonna hit enter. It says authenticating with existing credentials because I already have authenticated with this container registry. It will say login successful or something like that. Okay, you can see login succeeded. Now I'm just gonna do clear here. Okay, excuse me. I'm just gonna do a clear here. So let me just do a clear, and now. So sudo docker images, and now let's do one thing. Sudo docker tag chatbot img with AI anytime.azure.cr.io/images. So what I did, I just tagged this image to this container registry. /images means okay, all of my images will be within this images repository on ACR. So let me just do one thing. Let me just go to home again. We'll do this later once we push it. So now what I'm going to show is container registry. Now you can see AI anytime, and you have these repositories over here. Here you will see once we push this, guys. So what I'm going to do here is, let me just do sudo docker tag chatbot, and so let's do. So now I'm going to do push it. So sudo docker push. So once you do push AI anytime.azure.cr.io.images. Now what it's going to do is that it's going to push the entire image to this container registry, guys, and this will take time. So let's do one thing. Let's stop this video here, and as I said, right, this can be a series of videos. It can be a playlist, a separate playlist for LLM deployments. We can deploy all of our like couple of our bots, chatbots or applications on AWS and Azure. So also on AWS through Lambda and API gateways, and here with Azure on container instances and app service. So let's stop this video here, okay, the first video, and in the next video, once we push this to container registry, we'll use container instances and app service to deploy it on Azure itself, guys. So I hope you understood so far that what we did. So in this video, basically we have created a Docker image of the application. We tried it locally. We saw okay, it's running within a container. Then we created a container registry on Azure, and we also now tagged it and pushing it to the same container registry within a repository. And once it is done, we will basically deploy it through an instance or an app service. So I hope you understood, and let me know if you have any question or thoughts or feedbacks in the comment box. So you can find out the code on the GitHub repository. I'll also give that repository link in the description, and also the video link in the description with other links as well. So I hope you liked it. If you liked the video, please hit the like icon, and please share the video and the channel with your friends and to peer. That's all for today's video, guys. Thank you so much for watching. See you in the next one.